Welcome to Daily Papers, the podcast where we break down the latest and greatest research into bite-sized chunks. Today, we're looking at a paper that feels like it's been pulled straight out of science fiction.
It really does. The paper is from Google DeepMind. It's dated February 2026, and it's about an AI that can solve math problems. And I don't mean the kind of math problems you get in school. We're talking about problems that professional mathematicians work on.
Exactly. The paper is titled Aletheia Tackles FirstProof Autonomously. Let's break that down. Aletheia is the name of the AI, and FirstProof is the name of a very special math competition.
Right, FirstProof isn't your average math test. A group of professional mathematicians came up with a set of 10 incredibly difficult research-level questions. The goal was to create a benchmark, a really high bar to see what the current generation of AI is truly capable of. Think of it as an Olympics for mathematical AI.
So, Aletheia, our AI contestant, enters the arena. What were the results? How did it do?
It did astonishingly well. The paper reports that Aletheia solved 6 out of the 10 problems. And these solutions weren't just close enough guesses. They were full-fledged mathematical proofs that were then checked and verified by human experts.
6 out of 10 on a test designed to be fiendishly difficult for AIs is a huge achievement. But the most important word in that title is the last one, autonomously. What does that mean in this context?
This is the absolute key to the whole paper. Autonomously means the AI did it all by itself. The researchers were very strict about this. They basically just copied and pasted the problem text into the AI and then stepped back.
So there was no human expert whispering hints or guiding the AI toward the right answer, like a tutor helping a student.
None at all, and that's a massive step forward. Many AI systems that work on complex problems have a human in the loop, an expert who helps refine the questions or pick the best path forward. Here, the goal was true autonomy. The paper even discusses the philosophy of it. What counts as help? They decided to take the strictest possible approach. For the generation of the solution, there was absolutely no human intervention.
That's incredible. So what did the process actually look like if the humans weren't involved in the solving?
It's a really cool pipeline. First, they feed the 10 problems to Aletheia. Aletheia then works on them and produces candidate solutions. Basically, it's rough drafts of the proofs.
Okay, so it has its answers. Then the human experts jump in to grade them?
Not yet. This is my favorite part. They used another AI powered by Gemini 3 Deep Think to act as an automated peer reviewer. This second AI's job was to take Aletheia's rough draft, check it for rigor, and format it properly into a formal proof, just like one you'd see in an academic journal.
So an AI is marking another AI's homework.
Precisely. Only after that AI to AI verification process was the final polished proof presented to human mathematicians for the ultimate judgment, and they confirmed that for the 6 of the problems, the proofs were correct.
The paper mentions they actually ran 2 different versions of the AI, right? Aletheia A and Aletheia B.
Yes, and they took a best-of-2 approach. It's like having 2 brilliant students take the same exam. For each question, you take the best answer from either student. This strategy gave them the final result of 6 correct solutions.
What about the 4 it didn't solve? Did it just spit out nonsense?
This is another fascinating point. For the 4 it couldn't solve, it didn't just guess wildly. It either returned no solution found or timed out. The researchers say this is a critical feature. For an AI to be a reliable tool for scientists, it needs to know its limits. It's better for it to say, I don't know, than to confidently give you a wrong answer.
That makes a lot of sense. So for the 6 it solved, was it a simple thumbs up from the human experts?
Mostly. For 5 of the problems, all the experts who reviewed them agreed the solutions were correct. But there was one problem, problem 8, that caused a bit of a debate. A majority of the experts, 5 out of 7, agreed the solution was correct, but 2 had reservations. They didn't find errors in the math itself, but they felt some steps in the proof were a bit vague or sketchy and would need revisions before being published in a journal.
That sounds surprisingly human, like a real academic peer review process where people argue about the finer points of a proof.
Exactly, and that's what makes this so exciting. The AI is now producing work that is so complex and nuanced that it's sparking the same kind of high-level debate that happens between human mathematicians. It's moved beyond just getting the right or wrong answer.
So, zooming out, what's the big picture here? Why is it so important to have an AI that can solve math problems on its own?
Because it's a huge leap in an AI's ability to reason, to handle abstract concepts, and to produce long chains of verifiable logic. This isn't just about creating a calculator that's good at math competitions. It's about developing a tool that could one day work alongside scientists and researchers.
You mean an AI assistant that could help discover new things?
Potentially, yes. Imagine an AI assistant that could check a physicist's proof or find a novel solution to a problem in drug discovery or uncover patterns in complex data that humans might miss. An AI that can reason autonomously is a fundamental step towards that future. By the way, the name Aletheia is the ancient Greek word for truth, a pretty fitting name for an AI designed to uncover mathematical truths.
So, to sum up, Google DeepMind's AI Aletheia autonomously solved 6 out of 10 research-level math problems in the ultra-hard FirstProof challenge. It did this entirely on its own, with another AI even acting as its first-pass reviewer.
It's a landmark result, showing that AI is getting closer to being a true partner in scientific and mathematical discovery. And who knows, maybe by the time we actually get to the paper's date of 2026, it'll be solving all 10.